Novelx has miniaturized and driven the cost out of scanning electron microscopy. By leveraging silicon processing techniques, we were able to miniaturize the core technology inside a scanning electron microscope to something about the size of a sugar cube. That innovation allows us to deliver high resolution, sub-10 nanometer resolution, and low voltage imaging capabilities in a compact form factor, a system that's about the size of a laser printer that fits easily into available lab space without the need for any dedicated facilities, making scanning electron microscopy or nanoscale imaging capabilities conveniently available to users where they need them. What we talk a lot about is a distributed model, where historically folks have gone to a centralized scanning electron microscope, much like mainframe computers in the old days, to do their imaging. This is not convenient nor conducive to rapid cycles of learning and getting products to market quickly. What we're doing is distributing a critical subset of that functionality, sub-10 nanometer resolution, low voltage imaging capabilities, in a small system that can fit into a researcher's lab or closer to a production line. This is the core technology inside the MySem and the enabler for the innovation that we're introducing. This is called an FE-SEM cartridge. Just for comparison, in a conventional high-end field emission SEM, this was about a meter tall. We've been able to miniaturize it using silicon processing technologies to this small silicon chip here. That's about the size of a sugar cube, 10 millimeters on a side. We couple this with a field emission electron source for high brightness, high signal to noise ratio, high fidelity electron source. When these two are combined, this creates an electrostatic column that's capable of low voltage imaging and sub-10 nanometer resolution. What's really innovative, and why this is a completely different way to own and operate a scanning electron microscope, is that this is a field replaceable cartridge. It's rated for about 10,000 hours of continuous operation. When the electron source is depleted, as happens with most scanning electron microscopes, you don't have to do anything other than replace this cartridge and put in a brand new one that will then keep going. It's all done in the field by the user. This tool is optimized for low voltage imaging, making it ideal for looking at energy sensitive samples, soft materials, and biomaterials. Thin films, membranes, and a wide variety of biomaterials are perfect samples for being imaged with this tool. The low voltage imaging provides a really nice surface characterization without damaging the sample or having any of the negative effects of charging. The market reaction to the MySem has been phenomenal. For the first time, what we're able to do is to distribute a capability that was previously centralized at core facilities, forcing researchers and users to go to the centralized scanning electron microscope to do their imaging. This was inconvenient and not conducive to rapid cycles of learning or getting products to market quickly. What we've been able to do is to put a critical subset of the high-end field emission scanning electron microscopy capabilities into a small form factor that fits easily into their labs and is conveniently available when they need it to do the imaging they need. And what we found is that users such as UC Berkeley, UC San Francisco, Stanford, MIT, and Naval Postgraduate School at Monterey have been able to find additional uses for the tool because it's conveniently available to them.